Hello, everybody. Week number 8 lecture. So we got 4 more Q&A sessions for the semester. So, and then, by the way, your exam has been scheduled by the registrar office. I'm pretty sure you noticed that. It's actually April 20th, and then it's going to be a common exam to all the sections. Our section will be NNN, and also section O by the other instructor. So we'll give you more guides and more details about what the exam is going to be like. So don't worry, but if you really want to get started studying for your exam, which will be comprehensive, meaning that it's going to cover all the topics in the course, you may just maybe want to start maybe reviewing your lecture notes, tutorials, and also maybe like a details that you learn from the labs, things like that. So you may just want to get to it. But we will try to schedule. I'll try to schedule maybe some review sessions with you, given that it's going to be April 20th, about 1 week after your last day of class. So we should be able to schedule maybe 2 sessions at least to see how much you will need. But that's something we'll plan. Okay, don't worry. Okay, just a little bit about what you will do this week. For sure, I'm pretty sure you're busy preparing for your programming test number 3. And for those of you who didn't know, I actually had a review session last Friday to go over the complete solution to the practice test. So you can definitely try, give it a try on yourself with the 2-hour limits, and then you can compare with my way of solving it by watching the recording. So that'll be one thing you want to get busy with. For your lab number 7, which will be starting officially today until next Friday, not the coming one, but next Friday. So we are having a little bit digression from the Eclipse programming. So we are basically showing to you how you can build mobile apps in Android Studio, just another IDE. For those of you who actually asked me whether you can use IntelliJ, so there you go. So the Android Studio is a little bit very similar to IntelliJ experience, but we'll only stay there just for the labs. But starting from this week, I'm going to release the tutorial videos on Friday as usual, and we'll go back to Eclipse. We'll learn about 2-dimensional arrays to see how we can solve some challenging problems on going over the array. But we'll see some interesting problems as well. Anyway, just some introduction quickly for the week. All right, let's now move on to your questions. I see a good collection, as always, from the Google Doc. I check it about a few minutes before our session started, so hopefully that will cover everything. If your question is somehow not covered, just feel free to speak up, and I will be happy to cover that. Let's now start with the first one over here. All right, if we have time, can you explain why the default value for Boolean variable is false? Of course, we can talk about it. I think there are 2 aspects you can think about it. I think the real aspect is really about the implementation for the Boolean type. So you can think, so think it this way. So Java is actually so-called it belongs to the so-called C family language. And you will learn about the programming called C in your second year. So you will learn about it in EECS 2031. You'll learn about C. And C is so-called a procedural language without an OO. Procedural language without OO. And then, of course, Java came much later than C. And then Java is sometimes called a successor to C by adding the object orientation, which we learned from week number 6 to week number 8 in the tutorial videos. So what about Boolean type? So in the C language, I haven't programmed in C for quite a while, but at least that's something you can also explore yourself. In the C language, they have some standard, I believe maybe standard IO library, but you can check. I might be wrong in the about the exact library. But in one of the standard library, like an API library in C, they do support a Boolean type called bool over here. Okay. However, the way C allows you to manipulate the Boolean values is quite flexible, I would say. Well, if you're an experienced programmer, such flexibility would be nice. But if you're new to actually, the C programming language, in that case, this in some way may not be so disciplined when you use it. Okay, so I can see some of you said in the chat, C is your first language, but Java is new to you. Sure, I think it's interesting. Maybe you learned it in high school, maybe. Okay, let me give you one example. So let's say if you say Boolean some variable b, and then you can definitely say, I want to initialize that to be true, for example, explicitly. Okay. On the other hand, you can also reassign that to be some integer. Okay. If you reassign that to be 0, it would be it is as if you said it's reassigned to false. Right? If you reassign that to anything other than 0, for example, -1, -2, or maybe 3, let's say positive. So it would be as if you reassign that to be true. Okay, so that's just the C way, the way of C to actually handle Boolean types, which is pretty flexible. And then for certain programming tricks that rely on the Boolean value, you'll learn about it maybe in 2031. I wouldn't talk about it. Okay, so now how does that relate to the Java Boolean type? So you can think about, since Java is like a successor to C, so they kind of keep some legacy from the C language. So let's say this. So you can think about the Boolean value in the standard library of C is more like an integer, okay? And the idea would be, so basically 0 simply means false. Anything other than 0 simply means true, right? And the precise implementation about the Boolean type in C, I'm not too sure, but I believe something like an integer. So now what would be the default value for integer? 0, right? So the default value for integer would just be the 0 default value. So this is why when you try to declare, let's say in Java, when you declare Boolean, and then let's say B1 over here, you can think about behind the scene. So we kind of just inherits the heuristics that's actually from C. In which case, it would just be like a 0 for the integer, which will be corresponding to just false. So that is why the default value would just be false. So it's a little bit like, in some way, there's really no logical reasoning behind as to why exactly false should be the default value, but it's more like a legacy for the C programming language, right? Again, recap. 0 integer is the way to deal with the Boolean type in a flexible way in C. So for example, 0 for false and also not 0 for true. And since for integer value, the default value is simply 0, so that corresponds to false. So that's why I got false over here. Okay. However, I would like to add a little bit a logical aspect to it, which is kind of in additional, right? So if you think about it, if I somehow declare, let's say Boolean, let's say in Java, okay? So now I'm talking about Java. If I say Boolean B1, and then I simply keep that uninitialized over here, right? So now if you think about it, and now if somehow I want to use B1 in the context of some logical operation, especially for conjunction. Let's say if I try to say B1 conjoined with something over here. So here, so dot, dot, dot. So the dot, dot, dot over here can be arbitrarily complicated, right? So now you can see that the default value for B1 being false means that, so when we try to conjoin the false by default with anything else, does it really matter what this part is? It doesn't really matter. So that's why in some way, the default value will actually will just give you for conjunction for false. That means the developer should be really encouraged to really think about whether this particular default value is really what you intended for. If it is not, in that case, you will simply just get false result for conjunction trivially without any further calculation. So that's why there will be another aspect to think about it. Let me write it down. Okay, you can think about it. So now when B1's default value is conjoined with other expression, the programmer must think about whether the default value is really what you intended for. Otherwise, you should fix it. If the default false is intended. All right, so let me just some additional aspect I would like you to maybe think about. Okay, so conjoined. Okay. All right, guys, it's my response to the first question. Right? Any follow up to this? Anyone? Are we okay with the first one? Just about the default value. But of course, you know, you would if you just memorize about the default value of the Boolean value to be false, may not be so necessary. I would say maybe it's the best to think in this way. Think about Java is like a successor to the C language, and the way C actually treats the Boolean type is like a treating integer with the following definition, right? So that means if we simply got 0, that simply means false. So the default value for integer will just be 0. So that's why the corresponding default value for Java will just be false, right? That's how you can think of it. Yeah, Michael, you're right. It's more like a historical than logical, as far as I can see. All right. Any more questions about this? Any more? All right. Let me just move on to the next one. Okay. If there's no follow-up question to this. All right, this one's interesting. Okay, let me read it and then I will address it. Is it correct conceptually to say that reference type data or reference data type makes use of primitive type data in order for the reference type data to function and serve its purpose? I would say it's actually a very good point over here. I would say the answer would be yes. Reference type in some way indirectly manipulates primitive type. How? Let's think about a very let's say a very simple example. Let's say this. Let's say if I got I got a class. Let's not worry about public. Okay. Let's say I got a class. Let's say my app. Let's say your app actually try to deal with, let's say, two-dimensional points, right? Let's use a two-dimensional points example. And then we got our main method here. Let's say for console app, right? Whatever decoration is necessary over here. And if you just want to use primitive type values only, what you can do is you can simply say maybe integer x, maybe initially 0. So let's say we'll start from the origin. And also integer y is 0 over here, right? Let's say we don't really declare any template for our points. We simply use these two variables in our program directly, right? And then whenever you want to, maybe, for example, you might say y plus plus. So this actually corresponds to move up, right? In that case, you would just have to update the relevant variable. However, this way of doing things may not be so convenient, right? Because somehow you have to remember this is really these are the two data that you actually have to update or manipulate whenever you want to do with the points. It will be much better design if you try to do the following. Okay, let me just try to say this. So we basically try to factor out relevant data and operations into a template. And when I say template, I really meant a class. Okay, over here. So what can be the template over here? Oh, by the way, so what will be the data? You can think about these two are the data, right? We got X and Y. And also this one particularly, just for example, this will be the operation, right? Let's say we always want to move up, for the points, constantly. So now how do we define the corresponding template? So what we will do is we're going to define one customized type by declaring a class. So we would say class over here, and then we'll say it's a point. And inside this particular template, we're going to actually include all the relevant data and also operation. It's something called cohesion. So this will be some term you might actually run into maybe once you go to the third year when you talk about software design, but it's called cohesion. Okay. Cohesion simply means in a single class, if you're trying to do OO, in a single class, you're trying to put all the relevant attributes and methods inside a particular class, right? It's more like a judging criteria to see whether your design of classes is really appropriate. But that's something you will actually learn about in the third year. Typically, in your first and second year for CS, you are typically just given what classes and what attributes you really need to design. However, you're given, okay, how about this? You're given the design for the classes already with the predefined attributes, class methods that you must declare. However, you never actually just develop from scratch about thinking about what attributes and methods you will really need for your class. That's only the practice you will do in the third year, okay? Let's come back to this particular one here. So now let's put the relevant data. So I can say, for example, private X and also private Y. And let's say we've simply got a default constructor, and then we also got the operation, right? For example, the Y++. We can simply say void and then move up, for example. So this will be the operation to update the relevant data that's in the current template. So move up. Let me just say that one there is just going to move up by 1 units. So we can say this dot plus plus, this dot y plus plus. All right. So you can think. So this part here is really about the reference type, because we just defined that ourselves. So this really is the reference type. And the reference type itself will definitely try to make use of primitive values. So this is really corresponding to what your fellow student was asking, primitive values. And of course, based on what we learned between in your tutorial for the past few weeks, when you actually declare attributes, they do not always have to be just primitive type. They can themselves actually containing references to other types as well. So you can see the idea is really unbounded. It's really up to what you need for your application. Okay, one more thing to say. So now let's say after we have declared this particular reference type, so what we can do is we can now try to refactor. Refactor means we're simply just going to change the way we write a program, but we're basically achieving the same thing. So what we can do now is we can say points over here, let's say P, and then it will just be new P. You can think about this line, let me just highlight it. You can think about this line over here is basically corresponding to what we're doing over here, right? So now, rather than manipulating X and Y individually in your program, you're simply just using the point class, right? And of course, this should be point. And then how about this part over here, Y++, you would just say P dot move up. And that one there, depending on what the context object is, you're just going to modify the Y correspondingly, right? So Michael, did you ask the question or it was somebody else?
Yes, sir, it was me.
Okay, Michael, does it make sense to you?
Yes, it does. Thank you.
You know, it's a very, I would say it's a very insightful question over here. So I think to recap, so to really distinguish between primitive type and also reference type is as follows. Primitive type is we call it simple valued. It can either be 0, 1, true, false, maybe a single character, or maybe a simple string. But when you talk about reference type, it's really a complex type. It can be as complicated as you like because you actually got data and also you got operation. And the data themselves can also be references to other data types. So you can unbound it. So that'll be the difference between the two. All right. So Michael, any follow-up question to that, or you're okay? Okay. So primitive is enumerated data type. Well, I would say primitive simply just means simple valued. You just got a single value over there. And when you say reference type, you actually got a structure, in which case you got attributes and also you got methods, right? The fact that you actually declare P to be of type points, so that means all the attributes or all the methods that's actually defined in this particular class, you can call that upon this particular context objects. That's what you can do. All right. All right, any follow-up question to this before I move on to the next one? Anybody? All right, everybody seems to be okay. Next one. So for this one here, let's now, your fellow student was referring to this particular fragment of code. I believe if they are not really asking about how to trace it. Let's read the question. Is it then right to say that across a class's methods, method types, accessor mutator, if the two or more methods have identical names and also parameters, however, they got different return types, would that be okay? Why don't we ask Eclipse to try this? All right. I may not just reproduce this fragment of code, but we can take a look. So let's now try to see this. I'll just create just one dummy class over here. Let's call the class maybe called foo. Finish. Okay. And let's say what you said over there is you want to have maybe several methods with identical names and also parameter types, right? Just the same. Let's say this. For example, I can say I got integer, let's say method, method 1, okay? And then that one there will actually take, let's say no parameter, okay? Let's say return -1. So this is one method. And then I can say I got another method, which is also called M1, and also takes no parameter. So as far as the method name and also parameter list, for these two methods, they are the same, identical. However, let's say this M1 actually returns string. And then I can simply say return null. And apparently it's not okay, right? If you look at the errors over here, it will simply say duplicate method M1 in type foo. So when the compiler is trying to look at the two method, look at the multiple methods, they do not look at a return type. They do not look at it, okay? And like I can do another one. Let's say here I put string s. Here, if I put integer, let's say also string s over here, right? You can see name the same, and also non-empty list of parameters, parameter type, they're also the same, even though the name, or even though the return types are different. In that case, it will still be not okay, right? You must have distinct, either if the names are the same, that means you have overloading, method overloading. In that case, the parameter list must be distinct. Okay, that's for sure. Return type is not the judging criteria. Okay. Any question to this about this? So the answer to this is no. It's not valid. Methods.
Oh, wait, I have a question.
Yeah, one moment. Let me write it down. Methods with the same name. Bear with me. Must have. I think we said that as well in the slides. Distinct lists of parameter types. All right. Yes. Go ahead.
So if are you going to take marks off if we use an access modifier that gives more access than necessary? For example, if you only need access in the package, but we use public to be accessible across the entire project, are you going to take marks off
I would
for that?
say over here, yeah, you're right. Since I don't have any
Like
attributes here, it's only for illustration, but you should actually put public over here.
But what if you don't want it needed to be accessed as well through the entire project? You only need it to be accessible through the folder dot notation.
I would say in your programming test, for example, so all the methods suggested by the JUnit tests, if you didn't declare them as public, then you would have compilation errors because they exist in different packages. If you declare some additional methods, which you're allowed to, if you try to declare some additional methods in your class, you are free to declare them either as public, private, or simply package level. Either way is fine.
So you don't care about which access modifier you use as long as our code works.
Yeah, you can see that. We don't really focus too much on the modifier. Unless you're explicitly told that all the methods should be public. Otherwise, you're safe.
Okay.
All right. Any more question to this question here? This response over here. Anybody? Okay, so that's important. All right. Shall I move on to the next one? All right, the next one
Professor?
over here. Somebody?
Oh, sorry. Can you just quickly go back to the conceptual question? I just need to take a screenshot of it. Is that okay?
Which one, Michael?
The reference versus primitive type.
You mean this one here? Ah.
Yes. Sorry.
But Michael,
thank you.
I'll make the notes available anyway. So, but if you like to take a screenshot, yeah. But that's okay. You can take a screenshot, no problem.
Sorry,
Yeah,
sorry. Thank you.
I think the resolution would be better if you download my notes, right? All right. Okay, so now, Michael, did you ask this question here or somebody else?
I did, yes.
You did, okay. That's okay, let's go over one by one. I don't think you were really meant for me to talk about tracing, how to trace the code. Let's just answer one by one. I'll give you a short answer. If we had point move up by, does this mean that the first line of the body has to be something like this? Okay, let's look at this method specifically, right? If you look at this method here, let me see this. Oh, here. Let me just make it a little bit more thicker. So let's look at this method here. We can see that this method is an accessor, right? It's an accessor because it returns something. It returns specifically a point objects, like a reference to some point objects. Okay, so this is an accessor. And then since eventually we want to return a point objects, so a common way to do it is, why don't we simply initialize some local objects over here, MP, and of the same type as the return type. And then eventually we might do whatever updates we like on the MP, and then eventually we just want to return MP. So Michael, your first question, I would say yes. However, I would say this is not the only way you can do it, right? Because at the end of the day, at the end of the method, all you expect to see is to return the reference to some point objects. You can return whatever point object you like. All right. Second question. The point MP object has a local scope within the mutator. Yes, that's correct. Over here, you can see the MP over here. So this is basically a local variable within the scope of this particular method. Okay. Moved up by. For example, let's say if I try to do over here, if I say maybe MP dot maybe whatever method, right? I would not be able to do it because it's outside the scope. Okay, so that one, I hope that's okay. The third one. So now, was the objects MP created to differentiate P2 from P1? Okay, let's think in this way. Think about how this method here specifically is being used. You can see that we created P1 over here, and then when we actually call P1 the move up over here, we already spoke about the tracing in the lecture. You can refer to the video. So now maybe the question wasn't really about tracing it again, I don't think. So here, this part over here, we're basically modifying P1, the context objects, by calling this mutator method, right? So we're basically modifying the context objects, P1. That's what we're doing, okay? On the other hand, over here, what we're doing here, we are calling P1 the move up by. So we are calling this particular method move up by, right? And this move up by is actually an accessor. Okay, so what this will do is without modifying P1. So why you wouldn't modify P1? If you look at the body over here, the body of this particular method, you can see all we did was by creating MP and modifying MP and then return MP. So here you can see over here, there is no modification to this. Right? So that's a keyword. So you can see we didn't say, for example, this.x is assigned to another value. So we are not really modifying the context objects. the context objects, right? So hopefully up to this point, you're pretty clear about context objects, right? Whenever we're trying to make a method call. Without modifying P1, return the reference or address of another objects. Sorry, I'm running out of space, but objects over here. And then store that particular address to P2. That's basically what we're doing. So that's why you want to distinguish between using either a mutator over here versus using an accessor. In the case of mutator, you are modifying P1. You can see here, for example, you can see by calling the mutator, we are really modifying the current objects, the context object. Remember, implicitly, we say this.y is assigned to this.y plus I. So that's why you're modifying that. On the other hand, by calling this particular accessor method, you're not modifying it. You don't see any change to this in this fragment of code, right? In the body of the method. All right, so I would say, yeah, yes, but I think I just try to give you more detailed explanation over there. So Michael, is that okay?
Yes, so basically, every time you invoke the accessor method, you're creating another object, NP. Is that right?
Yeah, for this one particularly, for example, let's say if you got another accessor method, let's say you only return an integer, right? Let's say get maybe price. In that case, there's no need for you to create any object inside. It's just because the return type now happen to be a reference type. That's why we want to create that object to be returned.
I see, thank you.
Mm-hmm. Okay. Yeah, I think this particular accessor method here is a little bit new to you. I think that, but it's actually very common. That's why in the if you think about the context of talking, let me just go to that particular slide just to walk over that with everybody. I think that's really important. If you go to the classes and objects lecture, I forgot which slide it is, but let me just go there. About Java data type. Ah, there we go. Exactly here. Good. So now, when you review the lectures, maybe later for your exam, or maybe for your written test number 3, later, you can see that we can use the reference type over here either as the type for the attributes, right? You can say spouse, and then you can see it's a single valued reference type attributes, right? You can also say, for example, you can have maybe another attributes over here, maybe called children. And in that case, it could be person array, right? It's but of course, a person without any children, they will simply just got empty array, right? That kind of makes sense. And then you can also use reference type also as a parameter. That's also like an add points, add member we have seen. And in your practice test number 3, we also saw add points, maybe add members. It can be a member array to be added, right? That's something we did also last Friday. And then, so the one that Michael was asking is this one particularly. This one here, the return type is simply just a point objects. But we have also seen some other accessor similar to this. Let's say in the written notes, we spoke about the method get points in Trojan 1. In that case, it's also an accessor, and the return type is simply an array of points, right? So you can see in the body of the method, let me show that to you. It's always good to, review and connect what you have seen. If you go to the written notes, and I believe that's here, you can see this is just another accessor method over here, and then you can see that the return type is simply an array of points. So that means now accordingly, I'm expecting to really return an array of points. I can either just return, for example, this points. The type will actually work, right? However, it's not really the correct solution. What we should do instead is somehow create some intermediate local arrays over here. You can see 1 and also 2. And we for this particular solution, we need 2 intermediate arrays to figure out a solution. And then eventually you'll return just the reference to one of them, right? So that's kind of related. All right. All right. Any more questions regarding return values over here about this particular example?
Hello, sir. I wanted to ask a quick question about this. I don't think it actually matters at this stage of programming, but if we have a code that's actually long, and if we invoke method like this multiple times, I was thinking at each time we are creating new variables of which we pass the address and we don't use them no longer. So I was trying to know what happens under the hood. These variables that are once created, addresses passed,
Okay.
and not, are they canceled, deleted somehow? Like memory management question.
Yeah, absolutely. It's a very good question. It's a very good question. So let me try to rephrase your question in a way that everybody can understand. It's I can tell you it's a complicated issue, which we definitely don't expect to cover in this course. It has something to do with as you said, memory management. When you get to usually when you program in some object-oriented language like a C++, actually I shouldn't say C++ because they also support memory management, like a Java, C#. I think for Python, since they also support OO, so I think the idea about memory management, automatic memory management should be similar. So here's the principle. Whenever you have created an object, however, there is no other variable storing the address of this particular object. So we call this an often, like often objects, meaning that there's no way for you to refer to that particular object. In this case, that object will be automatically garbage collected. Okay, that's the short answer. Let me just say a little bit over here.
After the address is passed, it will automatically be deleted without even waiting. If it's
let me illustrate that. What you were talking about could happen in some cases, but not always. So let me try to explain that quickly for you. Let's say this. Let's say we try to call. Let me put it this way. Let's say here we got P2 over here. So that means P2 is going to store the return value from this method call, right? So now I'm not going to trace the detail for this particular method call. All you need to know is for this particular method call, you're going to create this NP, this local variable. You can think about this going to be a local variable NP pointing to some point objects over here. And then, of course, you're going to do some manipulation to it, right? Whatever manipulation you're going to do. And now what's going to happen is this. You can see P2 over here is actually going to store the address of whatever the return value is, meaning that P2 is going to point to NP over here, right? So now at this point, this object here is still considered as useful because you can see P2 can still refer to it, even though NP cannot refer to it anymore because NP is already outside the scope for its own method call, right? So NP in some way is already gone, right? However, we still got at least one variable like a P2 over here that's actually pointing to this particular object. So this object will not yet be garbage collected. Are you okay so far?
Yes. The variable MP though, it is not possible to gather it again. MP is deleted.
MP is deleted. Yeah, that's correct. Yeah. Yeah. Let me make a note over here. So you can think about MP. Let me just try to let's say this. MP over here. So this will be I shouldn't say deleted. It's actually it's going to be already invalid reference already. Invalid reference because method call already terminated, right? So after this particular method call is terminated, MP is becomes invalid because it's local, because method call ended. Okay, let me go a little bit further. For example, let's say this. Let's say hypothetically, I can add one more line after this line over here. If I say P2, the same P2 over here, if I say P2 is assigned to be, let's say, for example, new point, and then whatever it is. So what I'm doing here is I'm basically saying P2, rather than pointing to this particular object here, P2 is going to point to just another object. We can do this as much often as we like for OO programs. So it's going to point to this particular new object. So now at this point, so this particular object will be an often object. So now in this case, it will be a good candidate to be garbage collected. However, you cannot do it by yourself. You cannot do it manually. So you will rely on the automatic garbage collection of Java to actually do it at the runtime.
Oh, I see. I also made a little connection. Maybe it's out of the scope, but you know, forking in C, and if the parent dies, it's orphan, and then when the method ends or something like this, automatically all the orphans get deleted to end the program, or is it like? same logic, some kind of
when you
same.
say fork, actually fork is more about processes when you actually duplicate a process, nothing to do with over here. So I would say, let's not get confused ourselves over here.
Okay.
You are using an OO language like a Java, so the memory management will be completely automated, which means for you as a programmer, you never have to worry about if there's any object like this, even though let's say you got hundreds or millions of objects like this in your memory, but no variables is really storing their addresses. In that way, you're wasting your memory. You can assume that no scenario is gonna be like that at the runtime, because the automated mechanism for garbage collection in Java will handle that for you in a robust way. On the other hand, once you get to 2031, right, the course I spoke about in the very beginning, 2031, okay, in that course, I believe you will be given some assignments like this. I forgot it. Well, I did assignment like that when I was a student. You will be actually asked to actually maybe write some C program, and then you will be asked to actually free the memory as soon as a particular memory you allocated is not used anymore. So that's something you have to do manually. But in Java, you don't have to. So just want to distinguish between the two.
I see. Thanks a lot.
All right, good. I hope that's clear to you. Okay, it's something a little bit. You're right. It's kind of outside the scope for this course, but it's good to know. So you don't have to worry anything about memory management in Java. And similar, if you do program in other OO language like a C# or maybe a Python, you don't have to worry. All right. All right. Let's now go to the next one over here. The question is, if you create an array with some of the indices storing or pointing to null, I think storing, very good. I think storing null is a little bit more accurate, but pointing to null is okay. We understand what you mean. Will the null pointer exception only occur if and only if you try to invoke a method on those particular indices? Yes, that's correct. Okay, let's see some example here. Let's see this. Let's say if I got my person array. Person array, and then let's say PS. Let's use an initializer expression. So here, let me use anonymous objects. I can say new person. Let's say we just want to put a name. Let's say maybe Alan. And then the second slot, I can simply say null over here. Okay, and let's try the following. Let's try two programs over here. Number one, I would say for integer I, initialize to be 0, I less than ps dot length, and then I plus plus. Okay, let me just copy this because the second program will just share the same structure. Okay, and then over here, I'll simply say system.out.println. Okay, this is a console app as part of the console app. And then over here, I can simply say ps I. Let's say for the second one over here, okay, the second one here, and let me change its maybe color to be green over here. Okay, let's say for the second one, let's say println. PS I, let's assume the name attributes in the person class is private. So we have to say dot get name. Okay, so now we got 1 and 2. Oh, let me just make sure it's also consistent. All right, so now we got 1 and 2. So the question is, if we try to execute 1 or 2, are we going to, which one or which ones are we going to get null pointer exception, 1 and 2? Let's say it's a multiple choice, right? It can be 1, can be 2, can be 1 and 2, can be none. So what will be your answer? Let me put the question here. You can think about it. Which program or programs I'll see how everybody is thinking. So let's. So guys, if you're shy, just put your answer. Should it be 1, 2, 1 and 2, or none? Null pointer exception. Okay, 2, 2, 2. Okay. I think this one is quite obvious. However, I would say the principle is really the same. Okay. Null pointer exception really means you're basically trying to actually invoke or trying to access the objects that's actually pointing to null. You're trying to do something with it. If you only just want to print it out, it will just give you null. However, this one over here, when you actually get to the second slot, which is actually null, in that case, you're basically doing null dot get name. So this will actually give to you the null pointer exception, right? So I think the principle is easy. Of course, you have to see when you are given questions in the written test or the exam. So I would say the principle will be you have to trace the loop very carefully, iteration by iteration. If there's any particular iteration where you're trying to invoke a method on some null reference, in that case, you will get null pointer exception. Okay, but just printing it out will simply just somehow, yeah, just print it out. Printing that out will not give you a null pointer exception. Okay. Okay, this one here, hopefully that's clear. Everybody's okay? All right. All right, so this question here, if we want to retrieve private attributes of an object while in the same class, we can use them directly, correct? However, if the private attributes are in another class, we need to use accessor methods get name instead of name. Yes. So I think this is some questions which your fellow student, I'm not too sure if he's here, Ali. So he basically asked me about this. So I think it's the best to give you some principle, and then we can redo some of the example we did in the lecture, maybe on Eclipse. That might be the best. Okay. So let's say this. Let me give you the general principle over here. So we learned about the dot notation. So you can have whatever path expression to some context objects, and then eventually you will say dot. And then you have some attributes, I would say ATT. Okay. So you can think about this is a path to some context objects. And the context object should have a type, right? And also in your lecture, we learned about how you can infer the type for your context object, right? Let's say the type is simply C. So that means we actually got, let's say, class C, right? And then in class C, and let's say we got private, and then let's say ATT, let's say integer, ATT. And then you can see this, the important thing is you can see this attribute over here, ATT, is declared to be private, right? And now, will this particular access be valid or not? Whether it's valid or not depends on where you write this expression over here, okay? So there are two scenarios. Scenario number one, if you actually write this particular expression inside where this particular private attribute was declared, which is class C, if you use it over here, it will be valid. On the other hand, let's say I got another class. Let's say I got another class, maybe let's say class A. It's simply just another class other than C, right? So this is not where the attribute was declared to be private, right? So now inside over here, if I try to use this particular expression in the context of a class where the attribute, the private attribute was not declared, in that case, it would be invalid to do so. So that's the principle. So not too sure if Ali is here. Ali, are you here?
Yes, I'm here.
Oh, okay, you're good. Good, you're here. Okay, good. So
the explanation is clear to me right now. I just wasn't very sure about what the private meant and public
No
meant.
problem. You know, Ali,
I-
so let me, I'm going to do two parts for this explanation over here. Are you okay with the general description over here, the general one?
I am, yeah, your description right now, I understood it perfectly.
Very
But
good.
regarding the thing that I asked on the forum,
Yeah.
so when we are accessing within the same class,
Mhm.
after referring to another class and then referring back to
Yeah,
that class, like
exactly.
also a class.
Yeah, so let's now do it together. Okay, that'll be part two. So now this part one is only about the principle. Let's now do for part two. You know what, for part two, before I try Eclipse, let me try on the paper very quickly, okay? I think the one we can use is
Yeah,
this.
this one, exactly.
Yeah, I remember that, yes. I'm glad you show up today, so we can talk about it. Okay, so let's say this. So this is from your lecture notes. I think it's week number 8 about the dot notation, navigating between classes. Okay, so now let's talk about here. Okay, we are basically declaring this, defining this method here, getTitle, in the context of the course class over here. That's what we're doing. Okay, so let's try. Let me give you some example over here. Okay, let's try this. Okay. Number one, I can say, guys, let me give you a few so you can tell me whether it's valid or not. Bear with me. Give me a few minutes. I'll write down the example. Let me just mention something here quickly. Okay, so here is our assumption. For every class over here, we assume that the attributes are all private. I didn't say private here just because I didn't have space to put it on the page. Okay, so all the attributes over here should be private, and then correspondingly, they should have a public accessor methods. For example, for the student class, you really get public get ID, and also public get CS for getting the courses, and also get title, get prof, get name, and also get teaching TE. Okay, that's our assumption. Let me write at least a few. Number two. Okay, I think I can get
So
four.
the first one is not valid.
Yeah. One moment. Yeah, let's let everybody to read it as well. Yeah, we'll go over that. Don't worry. Yeah. Okay, I'll just get one more. All right. So guys, for those of you who want to exercise, I would suggest this, and then I can discuss one by one, and then I will consult with Ali together. So since he was the original one asking the question, so we can make sure he's okay. So the question is, choose all expressions that are invalid. Let's say invalid. Okay, 1, 2, 3, 4.
Should I speak?
Ali, just wait a moment. Let me just see if anybody want to answer, and then we will consult with you one by one. So guys, you can put the answer on the chat if you want to try. So now we are in the context of the course class. Okay, so which ones are invalid? So 1, 2, 3, 4. Which ones? There could be multiple correct answers, which means there could be multiple options that are actually invalid. Michael is wondering if it's only one that's invalid. Okay. Anyone else who want to try? I'll wait for maybe a bit longer if you want to try. Otherwise, I can just discuss one by one. And of course, we're now in the context of this particular class, course. Yeah, Ali, just one moment, and then I'll consult with you, okay? So Michael, you believe there's only one that's invalid? 1, 3, okay. Okay, let's now go one by one. So Ali, let's go one by one.
I also agree with Michael.
Okay,
because
so now let's say 1 here. What is 1 valid?
no, because course is actually within the student class, so we cannot access it with that
Very good,
notation.
very good, very good. So basically 1 is invalid because this over here, think about the type for the context objects. So since we assume we are now in here, so this will be course. And then CS is simply not declared in the course. Okay, so 1 is simply not valid. Okay, so let's talk about number 2. So now this will be the course. And then when you say prof, that'll be okay. It's simply referring to the prof. So now when you say get name, so now when you say prof over here, so that means this particular path expression over here, this the prof will give you the context object of type faculty, right? And so for faculty, you can definitely say get name. So that's fine. Okay. So now this one here is fine. Let me just say this. So this is okay. So what about the next one? The next one here. So when I say this the prof over here, so that means I'm now actually in the faculty over here, right? And now, can I say TE over here? That's the question, right?
If we are within faculty, we can, but I thought we were still like bound by the course class. So
exactly. So you can see that for this particular expression here, this is how you should analyze it. So now if you look at just this part over here, so this part over here is this the prof. So this will give you faculty, right? So we know that it's faculty. And then if you want to really get the private attributes, TE, we assume that all the attributes are private. If you're trying to access TE from faculty, you can only do so if the current class, this, is actually in the faculty, but we are not. We are currently actually in the course class, so you cannot do it, okay? So that's not good. Okay, let me put the answer over here. So TE is private and the context class, the current class, and the context class is not where it is declared. It's not faculty, it's actually students. Okay, so far 1 and 3 are not valid. What about 4 over here?
This is that's interesting because we are within the correct class, but the objects might be, and most of the cases are different. So different addresses, but the same class.
Yeah, exactly. Yeah, so the idea, so it's really about aliasing. You can think about different, for example, let's say different expression over here is like a different name. And then they might be just referring to the same objects. That's what aliasing is about. Okay. And what about this one here? Let's say here we say this prof is referring to faculty, and then we want to get a teaching. So now in this case, it's actually going to be going to go back to the course class, and then we are referring to the title. Would that be okay? Title is private.
It should be okay. Like
because we are now in this class, right?
Yeah.
Okay, very good. Exactly. So that's okay.
But the instance of the object that is returned by the getTE method might and is most of the time different than the object that is returned by this keyword, right? But still.
It's okay to be the same type. That's okay. You can see this, you're right. So this is of type course. And then this the prof is of type faculty. And then this the prof that get TE is of type array of course, and then go to index I, you get just the course. So you're back here. It's the same type. But being the same type doesn't really mean it will be the same object. It may be not. And then we're now in this particular course where the private attribute title is defined. So we can definitely say title. So that'll be okay.
Okay, thanks.
Professor?
Michael.
So just to clarify, like say for example, you start like hypothetically, this is possible. If you start at advanced OOP, like that object, and you somehow loop or not loop, but like go to software design, dot title is still valid because it's in the same class.
Michael, can you say it again? So are you saying?
Sorry.
Say it again, please.
So I'm just wondering, like say for example, you start at course advanced OOP, go to a path that leads you to. And you go to a path that leads you to software design. Is it still valid to say in this line of code dot title instead of dot get title because they're both in the same class course?
Yeah, exactly. That'll be okay. Yes, correct. That'll be okay. Yeah.
Okay.
Why don't we try this very quickly on the Eclipse? Okay, it's really good to make sure. Okay. Let's try this. Let me move to Eclipse over here. So
I actually remember how we use the keyword this as a reference. So other.spouse equals this type of thing. So if we are able to actually access the spouse attribute of the other thing as well, so within the same class, you understand what I mean? The spouse attribute, we actually accessed it within the same method to two different instances of the same class. So I think it will work in this case as well.
Yeah. Let's now write it down. Let's say this is your class person. So let's say we have some method. Let me just avoid, right? We just want to test with the method. Okay. Let's say we got private over here, and then let's say just person type, and then we got spouse. Okay, and then let's say in this particular method, of course, you can declare it to be public. Okay, and let me just add just a method here. And of course, if you say this dot spouse, this will be okay because this is a type person, and then you're referring to some private attributes spouse. However, that's okay because you're not in this very class. That's where the private attribute is declared. So you can also say this dot spouse dot spouse. This will also be okay, right? You can see this part over here. This spouse is a type person. And then you're trying to access the spouse attributes even though it is private, but that's okay. Since you're writing this particular expression over here, since you're writing this particular context expression inside the context of the person class where this private attribute was declared, so that's okay. So Ali, that's what you wanted to say?
If we give like a person other, let's say, as an argument to the method,
sure.
We can even say other.spouse equals.
Yes, you can say
this.
that. Yes.
So we access another instance, an instance that's different than this, and we can still access.
You can still do that. Yeah. So the idea is the context object for your dot notation. Right, again, remember the principle. If you got some dot notation and then some maybe attributes over here, assuming that the attribute is private, as long as the type over here is referring to where this particular private attribute is declared, then you will be able to do it. And also you're doing this expression inside that particular class, right? Let's say here.
But as Michael said, if it's null, it will be a problem, right? Like
let's say, if it is not, it will be a problem. Yeah, I'll do that. So let's say here person other, right? So now when I say person other, so now if I try, let me just put another line over here. If I say other dot spouse, let's say for example, so this will be okay, right? You can see this is a type person. So this is a type person. And then even though I'm referring to some private attributes, but I'm doing this in the very class where the private attribute was declared. So this is okay. On the other hand, let's do just another class over here. So let's say maybe class, I don't know. Let's say the shop, for example. And then over here, let's say here, owner. Okay. And then void, maybe some method m. So now if I try this, if I try to say owner dot spouse, would this be okay? Ali, you want to try? Would this be okay?
Hello. I couldn't understand. Private owner. What's the type of owner? What is owner?
Private person.
Oh, okay. Then no, it wouldn't be fine. No.
It wouldn't be fine, right? Because owner over here is actually person, and then you're trying to get access to the private attributes, not in the class where the spouse is declared. So that's why it's not okay. It makes sense to you?
It's clear. It's very clear. Thanks.
Okay, very good. So guys, apart from Michael and Ali, isn't anybody need some further clarification? Everybody's okay. All right, let me just try to do something quickly on the Eclipse over here. You can definitely try the expressions yourself. Let me, I already recreated. Let me put a food, maybe in the default package over here. I don't need a foo over here. Let me delete it. If you download the package from today, the projects, I already created a course, faculty and students over here, right? Let's say we go to the course over here and then get title, right? For example. So now if I simply say over here, return, let's say this dot prof, right? And then the prof dot, you can see the only, okay, so now you can see this. Okay, something you want to see this when you download the source code. When I say dot, the only thing that will be available to me will be the public accessors, for this particular context objects. This the prof is going to be faculty. Let's see what's there in the faculty. In the faculty at the moment, you can see I only got private attributes TE. So that's why I simply just cannot do it, right? If I try to do it, if I say this the prof TE over here, maybe a position I, that should be a course. And then I can say dot title. However, this is actually wrong, right? You can see it's wrong over here. I just cannot access the private attribute TE. You can see TE is a private attribute over here. I cannot access to it in a class that is not where the private attribute was declared, right? That's just reaffirming what we said, okay? So this one is invalid. This prof.te is not valid, okay? Let's do another one. On the other hand, if I try to maybe just define this public accessor, I just say return TE, just for the illustration. And then over here, I can say return this prof over here dot get TE, right? You can see now it's available, it's a public one. And then I want to go to some, maybe some index I. And now, can I, so now up to this point over here, up to here, get TE will actually give me an array of courses. So that will give me an array of courses. And then if I go to index I, it's going to give me the course. So now I'm now in the same class where the private attribute title was actually declared. So now if I say dot title, you can see it's actually available. It's confirming what we just said, right? So this will be okay. You can also say, so this will be okay. This is where, okay, let me say this. This the prof get TE I refers to the class where private attributes title is declared, right? So that's exactly what I just said. All right, so this is another note for you. Let's just do one more over here. Let's do something maybe very similar, okay? So rather than just staying in the course, right? Let me just copy this expression somehow, right? Let me just copy this. Let me now switch my context. If I go to, for example, rather than the course class, let me go to the faculty over here, right? So now if I say get title over here, right? Let me try this. You can see this expression used to be valid for if we put the current context to be the course class, but now we are in the faculty. So this is not a class where the private attribute title was declared. It's not. So now if I say this, let me fix this a little bit. I can say it's already the prof, so we can simply say this dot get te. Right? You can see now this expression here is not valid anymore. You can see this part over here, this dot get tei, right? So this dot get tei refers to the class where private attributes title is not declared. So that's why when this type over here is simply a type course. However, course is not a current class faculty, so you cannot access to its private attributes, right? Just confirming what we said in the illustration, okay? So Ali, does it make sense to you so far? Are you still here? Okay, maybe you're gone.
Oh,
you're here, right? Okay.
No, it makes complete sense. I got it.
Very good, very good. Yeah, Michael, I agree with you, but I think this is really something important for you to understand about OO, right? I think one of the fundamental ideas about OO is really to navigate between classes. But now the extra complication we have is you want to make sure you can only get access to something that's not private if your current class does not declare that particular private attributes. So you want to be careful, all right? All right, any more questions to this about using the dot notation? Any more questions? And I don't have any more questions from the Google Doc, okay? Any more question I can answer for today? I will pause here, and then if you got any more questions, feel free to bring them up.
Professor?
Michael.
Just a quick, I think you already answered this question in previous weeks. I can't remember when, but you clarified what the modifiers without anything. Then there's public, and then there's private. Like what does that do for this? Like what can be seen inside the package? What can be seen inside the project folder? Yeah. Can you please state that again one more time?
Sure. So maybe you know what? If you don't mind, let me find out that particular notes. So I can point to there. Let me just try to find. If I cannot find it, I will rewrite it. Give me one moment. It's either from last week or maybe the week before. Oh, this one here. So Michael does the notes. Let me be a little bit lazy here. I'll just copy this page. I'll reuse it. Okay, over here. So we got the top level is the projects. Under the project, you might get more than one packages, right? And then within every package, you actually got, of course, you might get sub packages as well. But you can think about sub packages, it's just like an individual packages, right? Let's not worry about sub packages. So under every package, you also got multiple classes, class A, class B, and also class C, okay? Let's say if I declare some attribute A to be private, what that means is only within this class can I actually get access to A, only within this particular class. That also corresponds to our dot notation, right? If I try to somehow write some expression over here, where you can see the context object here is OA, it's of type A. However, this context over here is not where this private A was declared, so I cannot really write it. So that's why it's wrong. So Michael, so far so good?
Yes, sir.
Very good. Okay, and then let's talk about if you don't put anything private over here, so that simply means in some way it's public with a limited scope. It's public only within this particular package. For example, you can see I try to declare some context object OB and then .b. So this will be okay because B is actually within the same package as A. So this will be fine. On the other hand, you can see here, let's declare another one here. Let's say class C over here. And then let's say we got some public integer, but let's before that. Here I can simply say B and then OB. So OB, the context objects of type B. However, I cannot say OB.B. I cannot say that because B is public only within this particular package since it has no modifier over here. If I really want to make B accessible by other packages, I should have declared that as public. On the other hand, if I try something I didn't write last time, you can see this particular variable is public, right? Let's say, for example, I can say in the context of B, I can try maybe C, object C is maybe new C. So now I have a context object of type C. So OC dot C. So that would be okay because you can see this OC of type C. And it's referring to this particular public attributes, which means it's visible outside its home package. So I could definitely use it in this class over here. Make sense to you, Michael?
Yes, thank you.
All right. All right, guys. Any more questions for me? Any more?
I have one more question, but I don't want to hog
no, Michael, it's okay. If you got more questions, go ahead.
Like maybe someone else who hasn't asked a question and wants
Let's
to
wait for maybe a little bit longer to see anybody else got a question. Otherwise, Michael, you can ask your next one.
I have a question that's not related to this lesson.
Okay.
So it's about the lab submission, about my email. So I sent you an email.
I think for your private email, we better deal with that privately. So why don't you drop by my office hour tomorrow, right? You may not want to share your private stuff, right? You know, with your fellow students. Why don't you drop by my office hour?
Okay.
All right, good. Anyone else? Any further confusion about OOP or anything else? Okay, Michael, you can go ahead.
Well, I think me just waiting to ask my question. I just thought of another question too. Okay, I'll ask the first one. Can we go back to the example we just did with faculty, course, and student? So with the way that these classes are set up, does this mean that we can't go from course or faculty to student?
Oh, no, we can. Remember what our implicit assumptions are. We say that every attribute over here, for example, every attribute here are simply private. You're right. Just by using attributes, I cannot say, for example, I cannot say that I can say this prof, that's okay within this context. But I cannot say this prof and then .te. I cannot say that. You're right. However, remember we assume that we also got public accessors to all the attributes, so you can easily navigate between without any problem. So you should really use the public accessors.
Because these accessors are okay. I see. Yes, I see.
Yeah, that's kind of since I don't have space for the page, that's why. Yeah.
Yeah. Can I ask a second question?
Yeah.
Or should I? Okay. I was wondering if you already clarified this and I just missed it, but I was wondering if you could tell us like how to properly use the terms shadowing, variable shadowing, and aliasing.
Oh, you mean shadowing versus aliasing? So they are very.
No, I mean, like I think in one of the previous tutorials I asked you like how to properly use the term variable shadowing, like what shadows what. Oh,
I see, Michael. You know what? I forgot to actually look it up. Let me look it up, and then I'll make sure I get back to you on this for sure on Monday, for sure.
Okay, thank you.
No problem. I think it's good that you remind me. I forgot. Okay, I'll make a note. All right, guys. Any more questions before I call it a day? Seems like everybody's fine. All right. Very good. All right. And I'm gonna end the session now. And then if you got any more questions, feel free to drop by my office hour, which is tomorrow and Wednesday. Otherwise, good luck to your programming test 3. All right. And then if you got any problem, get in touch. All right. Take care. Bye-bye. Zoom link, go to the top of the lecture site, and then you will find my Zoom link. If you just cannot find it, email me, and I'll send a link to you. All right, guys, take care. Have a good day. Bye-bye.